Moving on, number 66 of the final review. We have the multiplication of two polynomials. Okay? So inside each parentheses is a constant. Let's do the constants. Negative 2 times 6, that's negative 12. Now, remember the property. You sum the exponents. H to the first times h to the third is equal to h to the 1 plus 3 equals h to the fourth. So now we have negative 12 h to the fourth, I to the third, because we do 2 plus 1, j to the fifth. Okay, so we are looking for choice A. 67. Similar properties, but now we're doing parentheses with exponents. We have 2 times the unknown g to the fourth, h to the fourth, all raised to the fourth. This is going to be equal to 2 times 2 times 2 times 2 times g to the 16th. Exponent raised to an exponent, x to the n, right? X to the n raised to the m is equal to x to the n times m, right? So g to the 16th, h to the 16th. 2 times 2 is 4. 4 times 4 is 16. So this is 16 g to the 16th, h to the 16th for 67. Which is choice C. 68. What is given is a fraction. 2a to the fifth, h to the fourth, raised. Yep, that's the last one. What's in the numerator? 2a to the fifth, b raised to the third over 32b to the fourth. Okay? Now, we'll start this problem the way we did 67. We raise each thing inside the parentheses to the third power. That's 8a to the 15th b to the third over 32b to the fourth. Now, if we had b to the third upstairs and b to the fourth downstairs, we subtract those. So now we have 8a to the 15th over, no more b upstairs, we have 32b downstairs. This can be further simplified because they're both divisible by 8. So 8 divided by 8 is 1, so I'll just have 1a to the 15th over 4b. This is the final answer for 68, a to the 15th over 4b, which is choice B for 68. 69, we have given 20 m raised to the negative third n to the fifth over 2 m n to the negative 2 p to the negative 2. All right? So when you have these negative exponents, just put them in the other side of the fraction bar. So I'm going to move this one and this one and this one to the other side. So now I have 20 p squared n to the fifth over 2 m to the fourth, right? Because we had one m here in the denominator and the m to the negative 3 went downstairs, so it's m to the fourth now. Now we have 10 p squared n raised to the fifth over m to the fourth. This choice is choice C. Okay? That's for 69. 70. We have the scientific notation. Okay? So if we said, just for a quick review on this, 1.0 times 10 to the third. This is standard form because you have the decimal in between the most significant and the next most significant. So it's got to be A point A. So we need the decimal to be in the middle of those two most significant digits, all right? Also, we can say the same quantity, 1.0 times 10 to the positive 3 is the same thing as 1 times with 3 zeros, right? 1,000. But we could also say an equivalent form. It wouldn't be standard form scientific notation, but you could say 10 times 10. What would this one be? 10 times 10 to the second, right? What would that be? So we put the 10, and then this is times 10 to the second, so we put 2. So what I'm trying to say to you guys is 10 times 10 to the second and 1.0 times 10 to the 3. Those are equivalent forms, right? What about 0.1 times 10 to the fourth? What's that equal to? Well, if we slide this over to the right 1 unit, now we have 1.0 times 10 to the 3. Because we slid this to the right 1, we have to make this go down by 1. All right? Which is, we know, is 1,000. So they're all the same, right? So keep that in mind. For number 70, we are given 449 times 10 to the negative 10. All right? The negative exponent means that we're not adding zeros to the right of the most significant, we're adding it to the left. Okay? So to put this in standard form, we'd have to go to we'd have to go to the decimals here, right? So we go 1, 2. 4.49 times 10 to the what? 10 to the negative 8. Okay? So that is choice C for 70. 71. We have two numbers in standard form. 6.2 times 10 to the 5 times 5 times 10 to the what? To the fourth. Okay, these are both in standard form. So when we do that, we could just multiply the numbers. So I'm going to multiply this number times that number. 6.2 times 5. 2 times 5 is 10. Carry the 1. That's 31. So, but there's a decimal there. So that's 31.0 times 10. And now you sum these exponents. So that's 10 to the 9th, right? But since I'm going to the left one place value to make it standard form, 3.10 times 10, this has to be to the what? 3.10 times 10 to the 10. Okay? Because we took a bigger number, we made it smaller, therefore we have to increase that base 10. So that was, what choice is that? 71? That is choice C. 72. We have 39 in the numerator. 39 times 10 to the third over 6 times 10 to the negative 5, right? 6 times 10 to the negative 5. So, what do you do here? First do the division, 6 and the 39. 6 times 6 is 36. This is 6.5. So now we have 6.5, right? And we have to think about it. This denominator has a negative exponent, so it could go up to the numerator and make it positive. So you could do a 3 plus 10, 8. I'm sorry, 3 plus 5 is 8, so this is 6.5 times 10 to the 8. Okay? That is choice what? D. 73. We're out of the scientific notation now. 73, we have 8a minus 3a squared plus 7 plus 9a. Now, we look at the operation in between the parentheses. It's summing. So now we just combine like terms. Negative 3a to the second is the highest order exponent, so I did that. 8a plus 9a is 17a to the first, plus the 7 more. Which choice is that? That's choice B. All right, 74. We have the quantity 4a minus 4a squared minus negative 7a minus 4. So let's get rid of the minus right away. So we have 4a minus 4a squared plus 7a plus 4. Now we can just add the like terms. I distributed this negative to the other two negatives, and now I have pluses. Makes life easier. Negative 4a squared plus 11a plus 4. All right, so that's 74. That's choice A. 75. We have 3 times the quantity 4x plus 4 equals 2 times the quantity 5x plus 9 minus 12. Distribute. We have 12x plus 12 equals 10x plus 18 minus 12. We have 2x equals 6 minus 12. 2x equals negative 6. X equals negative 3. All right? That is choice D. Thank you for watching.